All right, so question number 5. We're asked. We have several questions based upon using the function that we got above and the information above from the investment to fill in the following blanks. So, so as you recall, this is the function that we got from the situation above. If you watch videos 1 through 4, and it was an exponential one. But I was also giving an example that if it would have been a linear one, this would have been the function here. Like, and I gave an example, if it went up by 10 every year, then it would be 10 times t for the time in years plus 700, or the beginning value. All right, but now we're being asked, what is the y-intercept of the function? Well, the y-intercept is the value you get when your independent variable, in this case t, the variable in your equation, is equal to 0. Now you can take your calculator and you can multiply 700 and then parentheses 1.3 to the power of 0. But if you remember, anything to the power of 0 is equal to 1. So this would just be 1 when I set 1.3 to the power of equal to 0. And again, if you're not sure, you can try it on your calculator. Well, so it would turn, this part would turn into 1, and 1 times 700 is just your y-intercept. And if you recall, for general exponential functions, the coefficient right here is going to be your starting factor before you begin at time 0, or when x or t is 0. So in our case, it's 700. Oops, got to get a pen here. So it's 700. Now, let's look at the linear function, because you could have gotten a linear function as well for the first 5 questions. Well, a linear, when you have a linear function, it's the same process. You could plug in a 0 for t and figure out what's left over in this side of the equation. Now, 10 times 0 would be 0. 0 plus 700 would be 700, and it would still be 700. So it's what's left over here. So again, it's the constant. The y-intercept is the constant in the equation for a linear function, and it's the coefficient in an exponential function here. Okay, what would the slope or growth factor be? If it's linear, the slope is the number multiplied by the independent variable. Usually we see it multiplied by x, like an mx plus b, but in this case, it's 10 is being multiplied by the t. So the slope would be 10, but again, in our case, the growth factor, it was exponential. So we look at the growth factor, that's the number here in the parentheses that's being raised to the power of something, of the variable. So here it would be, we would circle that, and we put 1.3 in this case. But if you had a linear one, you'd circle linear and put the slope, whatever's multiplied by the t. Okay? Now, the next thing is, what is the value of vt if t is equal to 6.5? Well, basically, I won't go through the process in depth as much as I did in question 4, because in question 4 we had something that asks us what would the value be if t, I think, was 17 maybe. So if you just got done watching that video, you recall that. But what this basically means is you're going to put wherever the function is, wherever there's a t, you're going to substitute it with a 6.5. So that would be basically right here. So let me go ahead and change the color so we can see that. And this again is if it'd be 6.5 instead of t. And if you did that on your calculator, let me go ahead and do it real quick, just so you can see it. You go 700 parentheses 1.3 to the power of 6.5, and you hit enter, and the result would be 3852. Now again, that is if it's exponential. So let's go over here and see what we do if it's linear. If it's linear, you just put 6.5 where the t is right there, so it'd be 10 times 6.5, that'd be 65, plus 700 would be 765 if it was a linear function. Okay? Finally, what is the value of t if vt equals something? This is actually kind of like what we just did, except in reverse. Here they're not saying t is a certain number and plug that value of t into the equation. Here they're saying there's a number that the equation is equal to for some given value of t. So how do we do that? Well, it would be like this. It would be basically 4392, and I'm going to do the exponential one first, is equal to 700 times 1.3 to the power of t. So we need to figure out what value of t would make this equal to 4392. Algebraically, you can do this by using natural logs, but what I'm going to do is I'm going to have you teach it by showing that you can enter this function into the graphing calculator and look at the table function. You may be familiar with it. So I'm going to go up to y equals, and I'm going to go 700 parenthesis 1.3 to the power of x. Oops, no, I made a mistake. It should be to the power of, oop, battery's running low. Okay, so go back this way. Okay, and I'm going to put my parenthesis. Okay, good. And then I'm going to hit delete. Perfect. Okay. So now this is the function. So now I'm going to hit enter, and then I'm going to, instead of graphing it, I could graph it, but I'm going to hit second table, and I'm going to start looking for values that are equal to the 4392 down here that we need to get. Okay. So when x is 0, it's 700, by the way, the y-intercept when x is 0. So I'm going to start scrolling down until I see, in the y column, until I see 4392. Oh, I think I just saw it. Keep in mind, this is 493.4, so that's a point. So that's it right there, and it's when x is equal to 7. So that would be the answer, okay? Oops, lost my pen. Oops, I'm about to run out of batteries. So it'd be 7. Now, if it was linear, I could do the same thing. The difference is I'd put in this equation right there. 10t is equal to 700. Let's do it real quick. Y equals, and go ahead and clear this one out. And I go 10. And by the way, it's going to be x, but so 10t or x plus 700. By the way, it would probably be a different number, but anyway, the point is I could go through my table and I could start looking at different values of x that would lead to different values of y. So let's just say it's 950. What is the value of x that would make the investment 950? So I keep scrolling down, try to beat the clock on my battery here. Oh, there it is. So y is 950 when x is equal to 25. So let's just say that that's what this was asking right here. When is this one equal to, say, 950? Well, I can use the graphing calculator to get a table. So that's how that last one works. Okay, so questions 6 through 10 are basically the same type of questions as 1 through 5. They're just a different scenario. I think it's dealing with fish. But the same process is the same. You look to see if something's linear or exponential, and I've already explained in the first 5 videos how to get the function for a situation, whether it's linear or exponential, and how to use those functions and how to analyze those functions. So that wraps up the videos for this study guide for analyzing functions.